The topic that we will be discussing today is about force vectors. In the previous topic, we already tackled the different types of quantities in mechanics. And then, at this point, we have two kinds of quantities in mechanics. These are scalars and vectors. When we say scalar quantity, these are quantities with only a magnitude is associated. For example, time, volume, density, speed, energy, and mass. And we know that these quantities, it has only magnitude. It has no direction. The latter one, the vector quantities, they possess both direction and magnitude and must obey the parallelogram law of addition as described later in this article. So the example of vector quantities, these are displacement, velocity, acceleration, force, moment, and momentum. And we know that a vector, it has a magnitude and at the same time it has a direction. So when we are going to set an example to this, let's say about distance, the comparison between distance and displacement. Distance is a scalar quantity because it has no direction, but a displacement is the measure of the length, but it has direction. So vector is the force vector goes like this. So we have a theta here. So the arrow is the magnitude. Okay, so for example here we have a figure for parallelogram law. We have two force vectors designated as f sub 1 and f sub 2, and then the f sub r here is the resultant vector. As you can observe, we have two congruent or two distinct or similar triangle. So if we're going to rewrite or redraw this one side of triangle or the half of the parallelogram, we can redraw like this. Okay, so all sides we designated as A, B, C. So side A, side B, side C. Side A, let's say that this is the first force vector, or this is the force given, and then B is the second force given. The F sub R here is already the C. And then we know that in trigonometry, the opposite angle of side A is the angle A. The opposite angle of side C is, let's say, angle C. And then the opposite angle of side B is angle B. So here is the derived formula or the two common laws in parallelogram law, and this is in accordance to the trigonometry. We have here the cosine law, which the equation is C is equals to the square root of a squared plus b squared minus 2ab cosine C. And then the sine law, this is a over sine A equals b over sine B equals c over sine C. Our first sample problem states that if the magnitude of the resultant force, or F sub r, is to be 9,000 Newton or 9 kilonewton directed along the positive x-axis, Determine the magnitude of the force T acting on the eyeball and its angle theta. So let's compare it, or let's see the figure here. So this is the x-axis, this is the y-axis. So we have here the T, the force T acting on the eyeball, and then the angle theta here, and then we have a 45 degrees here. Okay, so if you're going to get the free body diagram from this figure, we could say, or we can redraw the figure like this. So here is the y-axis, and then this is the x-axis. Take note that from the problem, it says here that the resultant vector is directed along the positive x-axis. So since this is the positive x-axis, so the resultant force moves, or it goes, the direction goes like this, going to positive x-axis. So as you can observe, let us apply the parallelogram law. So let us connect. So we have two forces, the force T and the force 8 kilonewton. So let us connect them. So we have now a parallelogram, four sides. Okay, so here is the theta, and then here is the given degree of 45. And then our resultant force, which is directed along the positive x-axis, is 9 kilonewton. So our next step is to know the degree here. So what will be the degree here? We all know that this axis y and the x-axis and y-axis are perpendicular with each other. So this quadrant, if we're going to recall the analytic geometry, this quadrant is, the angle is 90 degrees. So from the y-axis to the x-axis, the angle is 90 degrees. And then here is the theta. So in order to get the angle here, we could say that 90 degrees minus theta. So this is the angle here. Okay, so it is taken from the basic concept of plane trigonometry, that a perpendicular is in 90 degrees. So y-axis is perpendicular to x-axis, that is why this is 90 degrees. And we have a theta here, so the angle here is 90 minus theta. Or overall, if we add theta plus 90 minus theta, the total angle from y to x-axis is 90 degrees. Okay, now um, let us take the half portion, or the half triangle taken from the parallelogram, to use the cosine law and apply also the sine law. Okay, so our first target, okay, so this is the T, the force T. This is the total, I mean the resultant force, 90 kilonewton, and then the 8 kilonewton, the given force. So this is the 45 degrees. Okay, so why is we have here 45 degrees? So again, recalling our plane trigonometry theorem, we they are alternate ba yun tawag? I forgot. Basta the angle here, they are congruent, or they are equal. So that is the one of the theorem in trigonometry. And then 90 minus theta is also equal here. So the angle here is also 90 minus theta. So we can redraw, or we can draw the half portion of the parallelogram. So it goes like this. So our first goal is to solve for the force t. So in order for it to solve, we can use the cosine law, because we have a given two forces, and of course we have a given the opposite angle of the force that we are requiring to solve, which is the force t. Okay, so using cosine law, which is c is equals to the square root of a squared plus b squared minus 2ab cosine c, or the angle cosine times the opposite angle of side c. So based here in our figure, we are solving the force t. Okay, and then its opposite angle is 45 degrees. Okay, so again, let us recall the opposite angle of force t is 45 degrees, while the opposite angle of 8 kilonewton is 90 minus theta. Okay, so again, so let us back to our solution. Let's go back to our solution. The force t is equal to the square root of the square of the two sides, which is 8 kilonewton squared plus 9 kilonewton squared minus 2 times the product of two sides, and then cosine the opposite angle of t, which is 45 degrees. Okay, so using your calculator, we can say that the force t is equal to 6.57 kilonewton. So next, so how about if we are going to solve the force t using sine law? So it is also possible. Okay, so let's try this. So t over sine the opposite angle of t, 45, equals 8 the opposite over divided by sine the opposite angle of side this side, or this force, 8 kilonewton. As you can observe that we have two unknown quantity, the force t and the theta. So therefore, the sine law is not applicable in this kind of figure or situation. So let us try to solve. Okay, so at this point, so this we have here a typo error. So at this point, let us try to solve for the theta. So again, we can use the easiest way or the easiest method to solve for the theta. The theta is using the sine law, and we know that the sine law, uh, t side t, or 6.57 side t divided by sine of 45, or the opposite angle, is equals to 8 kilonewton divided by sine of its opposite angle. So okay, so let us put or substitute the given. So our t is a 6.57 kilonewton. So 8 here is given, and then sine of a 90 minus theta. So we are trying to solve the theta here. And then, so here is also sine of 45 degrees. So let us cross multiply. So 8 times of sine 45 degrees, and then 6.57 times sine 90 minus theta. Okay, so in plane trigonometry, we know that sine 90 minus theta is equals to cosine theta. So this is one of the trigonometric identities in plane trigonometry. So just recall or review the basic identities in trigonometry. So therefore here 6.57 sine of 90 minus theta equals 8 sine 45. We can substitute sine 90 minus theta is equals to cosine theta. So therefore at this step 6.57 cosine theta will be equal to 8 sine 45 degrees. Again, the cosine theta here is taken based on the trigonometric identities here. So if we are going to so let us divide both sides. So first we let us divide both sides by 6.57. So we have cosine theta equals 8 sine 45 degrees. And then let us and then we have to solve for theta, we have cosine raised to negative 1 or arc cosine 8 sine 45 degrees over 6.57. Okay, so in order to fully understand this basic simplification of the equation, please review the plane trigonometry or algebra. Okay, so therefore our theta here is a 30.57 degrees. Okay, so our answer will be the force T that is required in the problem is equal to 6.57 kilonewton, while the theta is equal to 30.57 degrees.